Now that we know how the tangent function is broken up by its period, let's look and see what effect a phase shift has on this graph. So here I have, in this example, a tangent function that I want to graph again over 3 periods, and we're going to treat it similar to what we did when we learned how to do both sine and cosine. I want my b, which is this value next to the variable x. I need it isolated. In other words, I need to factor this coefficient out. So I'm going to start by rewriting the equation by factoring out this value for b, in other words 2. So if I factor 2 out of both of those terms, I'm left with x minus pi over 2. So in other words, this is the function I now want to be looking at, the tangent of 2 times x minus pi over 2. And that not only allowed me to look at b individually so I can calculate the period, but it also lets me isolate and see how the phase shift is going to occur here. So we're going to start by, again, determining what b is, which we've said is 2, and therefore the period of this function would be pi over 2, because that's pi over b. And I want to, again, figure out what my asymptotes are. So the asymptotes come from the equation. Bx is negative pi over 2. Bx is positive pi over 2. So each time I have a b, I'm going to replace those with what I know 2 to be. So that's 2x is negative pi over b, pi over 2, and 2x is positive. So when I solve for x, I would divide by 2 or multiply by 1/2, and I get negative pi over 4 and positive pi over 4 for my asymptotes. Now the phase shift. The phase shift says that I'm going to be opposite sign here. I'm going to add pi over 2 to each of these vertical asymptotes. That's what the phase shift is going to get me on a tangent function. So the phase shift is going to be by positive pi over 2. So I'm going to come in and I'm going to add pi over 2. Oops, this should be pi over 4, shouldn't it? And in my calculator, if I don't want to do this fraction in my head, I can take negative 1/4 plus 1/2, and I would end up with positive 1/4. And I would do positive 1/4 plus positive 1/2 to get positive 3/4, which we write as 3 pi over 4. Remember, I can do math. I can add two fractions together as long as they're surrounded by parentheses, and then I do math frac inner to get the value right there. So what do I have going on here? I have, now let me get it to where I can see this, I have one complete picture occurring between pi over 4 and 3 pi over 4. Again, on this particular function, I had an not an amplitude, but I knew that a was equal to 1 so that I can mark that along the y-axis. So let me go in and let me divide up my graph. I know that I'm going between pi over 4 and 3 pi over 4. Those are my vertical asymptotes, okay? And then midway in between would be pi over 2. Now I'm going to go in and I'm going to draw my dotted lines, because too many of these tick marks at one time on tangent function kind of gets confusing. So what do we know about a tangent function? The period for this particular function is pi over 2. So to the right of this asymptote, I'm going to add 1/2, and to the left of this asymptote, I am going to add 1/2. Okay? So if I move in this direction, moving to the right, 3 pi over 4 plus 1/2 would be 5 pi over 4. And pi over 4 in the opposite direction, in other words minus 1/2, would be negative pi over 4. So at each of those new values that I just put on the graph, I'm going to draw vertical asymptotes. Then I'm going to come back in and I'm going to calculate the x-intercept for that function. So this function, halfway in between 3/4 and 5/4 would just be pi. And then in this section over here, halfway between negative and positive pi over 4 is 0. So I'm going to write the number 1 and negative 1 on here to represent values on the y-axis. And now I can come in and I can draw the curve. So I know that this function is increasing. So it's going to come up from the left, cross, and move off on the right. And it repeats this for all 3 sections. So that's how we're going to do a phase shift in for a tangent function.